Hello everyone and welcome to this session on OWL, the web ontology language. Today we will explore what OWL is, why it's important and how it helps machines not just store information but actually understand it. By the end of this video, you will see how OWL powers application in AI, healthcare, knowledge, graphs and even smart cities. Think of it like this. The web we use daily is like a library full of books written in different languages. Humans can read and interpret them, but computers struggle. OWL acts like a universal dictionary and logic system for machines, making sense of all this information in a structured logical way. What is OWL? OWL stands for Web Ontology Language. It was created as part of the Semantic Web vision by the W3C. Unlike plain data formats, OWL allows us to represent knowledge in a way that both humans and machines can understand. It extends RDF, which is a framework for describing resources on the web, and adds richer vocabulary to define classes, properties, and logical relationships. What makes OWL powerful is that it enables reasoning. That means new knowledge can be inferred from the existing facts. Why do we even need OWL? Well, the traditional web is designed for humans. It's mostly text and links. Machines can process text, but they don't truly understand the meaning behind it. The semantic web aims to make data machine interpretable. OWL helps by providing a standard way to represent knowledge with meaning. For example, if one system says car and another says automobile, OWL can help align them. This makes OWL crucial for areas like AI, knowledge and graphs, healthcare data exchange, and even in IoT systems. Now let's dive into the building blocks of OWL classes. Think of these as categories or concepts. For example, person, vehicles, animals. Individuals. These are actual instances. John is an individual of the class person. Car 123 is an individual of class vehicle. Third is properties. This describes relationships. First, object properties connect individuals. For example, John owns car. Car 123. Data properties connect individuals to literal values. John has age 25. Axioms. These are logical rules for statements. For example, all humans are mortal or every student is a person. Reasoning. The real magic of OWL. If John is a student and all students are persons, then without explicitly writing it, a reasoner can infer that John is a person. This kind of reasoning is what allows knowledge graphs, search engines, and AI assistants to make smarter connections. Versions of OWL. OWL has evolved over time. OWL 1, released in 2004, was the first official standard. OWL 2, released in 2009, expanded capabilities and introduced three profiles. First is EL, optimized for every large ontologies like those in healthcare. QL, designed for database style query. RL, based for rule-based reasoning systems. These profiles make OWL flexible. It can handle huge medical ontologies with millions of terms, or it can power lightweight applications that just need rule checking. OWL versus RDF versus RDFs. It's easy to get confused between RDF, RDFs, and OWL. Here is the difference. RDF is the foundation, just triples like subject, predicate, object. RDFs adds a cause schema. You can define hierarchies like dog is a subclass of animal. OWL goes even further. It allows rich logic rules and reasoning. So while RDF and RDFs are about describing data structure, OWL is about understanding and inferring knowledge. It's like moving from a dictionary RDF to a taxonomy RDFs to a full logical knowledge base OWL. OWL syntax and examples. OWL can be expressed in different syntaxes. For example, XML, Turtle, and Manchester syntax. Manchester is the easiest to read. For example, class person, subclass of mammal, class student, subclass of person, individual, John, student. Here we have said that person is a subclass of mammal, student is a subclass of person, John is a student. Now with the reasoning, owl automatically infers John is also a person and John is also a mammal. This shows how owl makes knowledge hierarchical and inferable. Next is the applications of owl. Owl is not just academic, it's powering real world systems. For example, first is healthcare. Owl is behind biomedical ontologies like SNOMED, CT, and Gen ontology. Doctors, researchers, and AI systems rely on this to standardize terminology. The first, second is knowledge graphs. Google's knowledge graph uses ontology-based structures to improve search results. Third is e-commerce. Owl helps standardize product categories and makes recommendation more accurate. Smart. Fourth is smart cities and IoT. Devices and systems from different vendors can talk to each other because OWL provides shared meaning. Next is the AI and machine learning. OWL provides structured background knowledge that can complement machine learning. For example, an AI model might learn patterns in data, which OWL ensures the knowledge is logically consistent. So, what are the pros and cons of OWL? Benefits. It is very expressive, letting us capture complex relationships. It supports automated reasoning. Systems can discover new knowledge. It enables interoperability. Different systems can share meaning. It's widely adopted in research and industry. Limitations. Ontology design can be complex and requires expertise. The learning curve is steep. Reasoning can be computationally expensive, not ideal for massive real-time data unless optimized. For simpler data tasks, OWL might be too much. Plain JSON or RDF may be enough. So the next is tools and reasoners. Fortunately, there are great tools to work with OWL. Protégé is the most popular ontology editor developed at Stanford. It lets you design, test, and visualize ontologies. Reasoners like HermiT, Pellet, and Fact++ plugs into Protégé or some other platform and let you perform logical inference. APIs like Apache Jena and OWL API let developers integrate ontologies into their applications. These tools make OWL accessible whether you are a researcher or a student or a developer building real-world systems. To sum up, OWL is one of the most important technologies for the semantic web. It enables machines not just to store data but to understand and reason with it. It has wide application in AI, healthcare, knowledge graphs, IoT, and beyond. While OWL can be complex, its ability to add meaning and reasoning to data makes it a cornerstone of the future web. So the next time you see Google give you a direct answer instead of just links or a medical AI making logical recommendation, remember somewhere in the background ontologies and OWL may be at work. Thank you for watching.